What's up, everybody? In this video, we are going to learn about digital inputs and outputs. When we build a circuit with an LED, we built a digital output, but we did not formally identify it. In this video, we will introduce inputs and build a circuit with an input and an output. During this course, when we talk about input and output, we mean relative to the Arduino. The Arduino is essentially a brain that connects to a series of components. Each of these components is either an input or an output. What is the difference between an input and an output? An input is an electric signal that moves into the Arduino, and an output is an electric signal that moves out of the Arduino. We can use inputs and outputs to detect when a button, an input, is pressed and turn on an LED, an output. Remember, when coding the Arduino, in the setup function, we identified if a pin was an output. We can also identify if a pin is an input. When we refer to digital and the Arduino, we are talking about components that have only two states. When we use the digital write function in our programming, we set a pin to either high or low. We could also use the values 1 or 0, and true or false. In all cases, there are only two states. This is digital. To help you understand inputs and outputs, we are going to build this circuit together. We will use two LEDs and a push button. When we start the simulator, you will notice that one LED is always on and the other turns on when we press the button. The button is an input, and the LEDs are outputs. We are using the Arduino as a power source. There is no code needed. A button is a new component. Before we wire the button, let's understand how it works. A button has two sides. Each side has two legs or terminals. The terminals on each side are connected to one another. So side 1, terminal A, is connected to side 1, terminal B. And side 2, terminal A, is connected to side 2, terminal B. When you press the button, it connects the two sides. To build the circuit, log into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup circuit. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to LED-push button. Fill out the information in the header of our code. Update the program name and description. The program name is LED-push button, and the description is a sketch where we will use a push button to turn on an LED. If you take a button from your kit, you will see that the legs stick out from the body. This is how we will align it to fit into our breadboard. Select a button from the components and add it to the breadboard. You will notice that the button fits perfectly over the Great Divide. Since the sides of the buttons are connected, this means that pins A to E on one side of the breadboard are now connected to pins F to J on the other. This is only for the terminal that the button is connected to. So in our case, it is 3 and 5. If you hover your mouse over the connection between the button and the breadboard, you will see that the terminals are labeled 1A, 1B, 2A, and 2B. We are going to add an LED. Select an LED from the components and add it to the breadboard. Remember that we need to have a resistor to reduce the current flowing through our LED. Click on a resistor, rotate it using the R key, and place it on the breadboard. Change the resistance to 220 ohms. Add a black wire that connects the cathode of the LED to ground. Our first LED is going to always be on. We are going to use this LED to confirm that the sides of the button are connected to one another. Add a green wire from the end of the resistor to terminal 1A. Now add a red wire from power to terminal 1B. Start the simulation and the LED will turn on. This is because whether the button is pressed or not, the terminals on side 1 are connected to one another. Now we will add a second LED that turns on when we press the button. Select an LED from the components and add it to the breadboard. Click on a resistor, rotate it using the R key, and place it on the breadboard. Change the value to 220 ohms. Add a black wire that connects the cathode of the LED to ground. To connect our LED, we are going to place a wire connecting it to side 2. Add a yellow wire from the end of the resistor to terminal 2B. If we test our circuit, you will now see that the bottom LED is always on and the top LED turns on when we press the button. For the LED that turns on when the button is pressed, it does not matter if it plugs into terminal 2B or 2A. We can rewire the yellow wire and the circuit still works. This is because the terminals on side 2 are connected to one another. At the end of this video, you should have a better understanding of digital inputs and outputs. You should understand how a button works and how to turn an LED on and off using a push button.